created this huge mind map in the
Yeah,
last couple of days about
absolutely.
DevOps.
Yep. And how to get into DevOps mainly,
Yeah,
like what the skills are needed and what we
that,
see, and like the cool thing about rolling into the role, so to speak. In the past, it's cool to see what skills we sometimes need or what we see, like with like when people are coming over for job interviews and stuff like that. What skills sometimes are lacking and need some improvement, where we can assist. So it's yeah, it's a very yeah, quite advanced mind map. So
it's not
let's
it's
dive
not a
into it.
junior role,
No,
DevOps.
no,
So I think when I was creating the mind map, I was just like, okay, what do you all have within DevOps? Um,
yeah,
and
absolutely.
then you just have a lot of technologies, a lot of different kind of industries within IT that you have to know about. So it can be a junior role, but you still need to have like guidance or someone in your team that is more senior, or you just need to know a lot of stuff.
Yeah, of
Yeah,
a lot of components. That's also interesting because like this is built on our experience. So if anybody feels that something is lacking or whatever, can always put it in the comments, and then we can see from there why we missed it or whatever. But yeah, but let's
yeah.
jump right
There,
into it. I think like the
there
first
might
step.
be there might be stuff lacking. There might be some topics that I didn't add.
Yeah,
Um,
exactly. That we
yeah,
missed.
yeah. But I added a few things that I find important that might not be in other blogs or people explaining like what do you need to know. So this could be quite interesting. So indeed, so let's have a look at this mind map. So in the middle you just have DevOps. What is all in DevOps? What do you need to know to get into DevOps? Okay, so DevOps is a culture, right? So but within the culture,
Yeah,
you also need what do you need that is not a developer. So developer is quite well defined, someone that programs in a certain language, he knows his tooling, he builds his application. But then who are the infrastructure people that should surround this team, should help this team? And okay, so you will be responsible to get the app deployed, running, to maintain it. But what are now the skills that you need or that you could
hmm
um, be exposed to? And actually, if you and let's start at the left top. If you need to get an understanding of okay, you have application development, but what if the app is running? What nowadays? What do you really? What is the basis of understanding that you need? Like, what is the kind of lowest level of understanding that you need? And I think it's just networking is a first thing. Like, how does the internet work? Like, do
yeah,
you know
absolutely.
when someone makes a request to the application, it's now often running not local anymore, but just on the internet. It's a SaaS application. Like, what happens? DNS is the first thing, one of the first things. DNS, we type in a name, it needs to be resolved to an IP address. But what is TCP/IP? Like, what are the ports that need to be opened? Is there a firewall? I think that the first one, if you want to get into DevOps, one of the first courses you should be looking into is maybe just like you have these courses from Cisco. The certification teaches you the basics,
Basic, yeah,
some
absolutely.
basics. But I'm sure there are much more. But that's how I learned it. You as well, I think. No,
Yeah,
did
yeah,
you do
absolutely,
that?
absolutely.
Like, this is like the basics still in university. Like, let's just like what is all this stuff? What is an IP address? How does it get routed over the internet?
Yeah,
Subnets,
definitely.
all this kind of stuff. This comes back immediately. You will
Yeah.
definitely see it once you set up networking in the cloud and stuff like that.
Or when something is not working, it still helps us debug stuff as
Yes.
well. Like
Yeah.
just
Well, like
because you have that basic understanding. Because this is also interesting. Like when we are interviewing people, one of the questions we often ask is, you have a website. How do you get to it? What are the steps needed to get to that website? And then the next question is on how to deploy it. But and it's interesting to see where people start from. Some are like, yeah, you make a request, go to DNS service. Some people are like, yeah, you type it in the browser, for example. But it's always interesting to see where like on what layer it starts for some people.
And so you have like light is going through your fiber.
Yeah, exactly. Like you have electricity, and then you have ones and zero, like stuff like that. Yeah, it's. I find it fascinating that everybody. It's a unique answer. Yeah.
Yeah, there's an Ethernet frame.
Yeah, exactly.
Your computer is going to do an ARP request to find a router, to find a DNS server.
And they immediately find people's strengths as well, and what their bases are. But that's
yeah.
just...
I think also we are maybe already a bit old school, because we are already so long in the industry. So these courses, like networking, TCP/IP, the OSI model, we kind of grew up with that, I think, because nowadays, and I have this idea as well. Nowadays, people like, okay, you have all these abstraction layers. People kind of plug in the top abstraction layer, Okay, what is Kubernetes? What's cloud? But cloud and Kubernetes are built on so many things. And what is under it? So we actually have to learn all these layers under it to fully understand it.
Yeah, for sure.
So I don't know why I put this on networking. Maybe I should put this, system administration. System administration is also a big one. It's just like one topic here, but it's such a big one. System administration of Windows and Linux, maybe Unix as well. I don't know if a lot of people are still running something else on Linux. I'm sure some people are like, sometimes on Hacker News I read something like, oh, I'm still using a FreeBSD, NetBSD, like, oh wow, I haven't heard about this in 10 years. Still exists, yeah. So depending on the company that you work at, it's often going to be Linux or Windows, one of these two. So you kind of know what to look for. System administration, in Linux, there's also scripting, and in Windows as well. Scripting, Bash scripting, or just in Python, like automating things that you need to do. Like, for example, this comes back. Let's say you need to start a Docker container, a VM. Well, you often need some commands, maybe before you start application. Maybe you do something, prepare something. So you just need to know, the basic commands, the basic like cd, make a directory, change permissions, ownership, like what is all happening. And then what I find interesting as well is people often don't understand how complicated all this container technology is. Like, what does it do under the hood? It does actually quite a lot of stuff once you start looking into it. Just spinning up a container is like, and all these mount mappings and these C groups and these making sure everything is isolated, and then doing the routing for the networking. There's a lot of stuff going on, and then it goes then back to the previous topic, networking.
Mm-hmm.
How let's say you launch a container, how is the port mapping done? Like, what is it? What makes it happen? This port mapping. Okay, you have IP tables in Linux. IP tables. They add IP tables routes. Then you have to learn IP tables.
Definitely.
Which is not even here. Going to add this IP tables.
It makes you like more. How should I put it? Like you get a lot more understanding about how everything works.
Yes.
You go through those steps and do not work bottom down, but down up. Then you feel way more secure when you're like running to an issue, and it's not all like a black box. Like I type this command and it does that, but then in the background I can have a look at this or this or this and find your way. And it's more about building self-esteem as well in running systems and important systems, and those happen from the ground up. Yeah, true.
If you understand how a system is built and how it runs, then if something goes wrong, you understand what needs to happen. But if you don't really have any idea how the system works, then you kind of at that point need to start learning how the system works. It's not that we know everything, right? If we don't know. Something happens, okay, what is the system, how is it supposed to work, what should I do? And then you just kind of do a deep dive in that system. But I think we have it easier in a way that, let's say you start a day, okay, there's like 100 topics that you have to learn about. But before there was DevOps, we already know about networking. We already knew about IP tables, Linux, system engineering, all this kind of stuff. So for us, it's like we already knew all these things, and then now DevOps, the term, the terminology, that kind of people start using that, and then you have cloud, and then for us it was super incremental, and that's why it's so difficult now. Like it's just overwhelming. Yeah, to jump in, so overwhelming. It's like, what is all this stuff? Yeah, you need to start somewhere. Yeah.
Our first way of automating thing was scripting. Like there was you
yes,
had Perl, you had Bash. That was it, right? Like and that's how people now. It's like, should I do it in Bash, Python, Go?
I remember
like so many ways now as well.
I remember reading a long time ago, Google is using Python, and I was like, Python, maybe you should look into that.
Yeah, exactly. Yeah, but it's all done incremental, like you said.
Yeah, because then it's like, Python, okay, I'll look into Python. But these Perl scripts, should we still use these Perl scripts? Python looks easier to use. Yeah.
Also a training that I used to follow, like an exam that you can do, LPI.
LPI,
also covered a lot of Linux basics that helped me understand those things, because you don't come in contact with C groups that often, like and if you then have to learn it, that's always good to like pinpoint an exam and just do that, because then you learn all stuff that you don't frequently use.
Yes,
you at least know it exists.
Yes, my LPI exam didn't include C groups because it was way too long ago. It still included Win modems, and these questions I couldn't answer because I had no idea.
No, true. Yeah, I haven't looked at it in like 10 years or something.
No, they updated it. They updated it. Yeah, I looked at it recently. My certificate still exists.
Wow.
The website can still verify my certificate. Yeah, but they updated their courses for sure, and now it's all more modern things. Like even at that point in time, Win modems was already not used anymore. IP chains, yeah. I think when I did the LPI exam, they said, I think I don't think IP chains are still in there. I think they used IP tables, which was new.
Yeah. People already had to recertify for that.
If you know what IP chains is, then you're our age.
Yeah.
So let's go a little bit. Yeah, no. It's interesting to see also how we differ compared to younger generations that indeed have to learn all these things, maybe not at once, but they have to learn all these things. But we, for example, with the people that we work with, we can just guide them. We say, look, all these things you will have to eventually learn. Cloud, now spend some time on networking, spend some time on this, security, and so on. Yeah, and then, that's kind of how you upskill. You don't upskill by just knowing a lot about AWS. You need to know about AWS, but also about other industries, topics, and then all this together makes you a better engineer.
Yep, absolutely.
So then the build tools, and I found build tools interesting because I remember when we started working on builds, like pipelines, deploying applications, build tools is kind of the first thing that you come into contact with. So I think before like the DevOps movement, it was really like a developer thing. Like the developer just he or she uses the build tool, packages an artifact. Here's the artifact. Now it's your problem.
Do your thing. Throws it over.
Yeah, indeed. But now that DevOps should remove the walls. We should all work together, dev and operations. So operations has a like closer look also to the build tools and the pipeline, because you kind of work together to see what is the best way to get this deployed. And then you also then get exposure to npm, package manager, maven, gradle, even makefiles, like the way that it's being built, because it's not built on the laptop anymore. Maybe in the past we would build so much more on the laptop. You build your jar and then you send your jar over, and it's like, okay, let's deploy this. But now it's more like, I think the first the way we were doing it was with Jenkins, right? It was even called something else before. What was it before Jenkins? And
No.
Jenkins and then, but there were also some other tools. IBM also had some tools, very clunky tools.
Oh yeah.
Something with logic, I don't remember.
I decided I wanted to more go the DevOps direction, because I knew it existed already. You saw it, like it was. You saw the movement coming up and saw all the tooling coming up. And back then I was working in a bank, and we had this awful tool. It was built by like IBM or whatever, or BMC or something like that. It was
yeah.
such a pain.
And then you just had like all these plus signs, and then you can like dig deeper, and
then release, and then just hope, and then you had to. There was like, first to deploy a simple package, you were longer working on actually creating the package to be deployable by the tool than it was to just like create the system yourself or whatever. It was completely crazy.
and then Jenkins, wow, it's Jenkins.
Yeah, but that was the thing. Like in most, I still remember we used like a kind of it was a weird terminal that we had to use for SSH, and then they like PuTTY was around already. So in Windows, to make SSH connections, you used PuTTY. Like everybody was using it, but it was not a commercial product, so they couldn't buy support from it. So we were not allowed to use it, and so people smuggled it in the background on a shared drive, and then people were using the tool all the time but there was no support, and that was the thing. Like, oh, Jenkins, there's no commercial. Was at least no commercial support for it, so you're not allowed to use it because it's a. I was like, oh my god.
Yes, I remember like open source in certain enterprises, people didn't want to adopt it because they just couldn't go to a company and say, I will need to call you when I have an issue.
That never happened, but it was like, pay you millions and be sure that we can call you instead of like have to figuring it out ourselves, which kind of makes sense on some points, obviously.
But you see now, I think that also, but this may be a little bit off topic, that a lot of these open source technologies actually have now a big company behind them.
They also have to pay their bills. Like you just saw it in the acquisition of HashiCorp as well. I think like they managed to get around quite long, but yeah, at the end, they need to commercialize. It's like Docker as well, right? We talked about it in the past as well. They set along all this movement and then failed to like monetize it. So I think a lot of companies are trying to switch earlier than they used to do it in the past.
Yes. Yeah. So yeah, build tools. It's not that you need to be kind of very deep into it, but you need to be aware. You need like the way I see it is like the developer should still own like the what goes in the pipeline code, like the Jenkins file or the Bitbucket pipeline or GitHub Actions. But you also need, if something goes wrong, you need to give support on it. So you need to kind of know, okay, Maven, what is it doing? It's packaging now. Something happened. Is it on an infrastructure level, or is it a developer mistake? If it's on the infrastructure level, you need to make some changes maybe. And yeah, it's all interweaving now, because you run that Maven within a Docker container maybe, and then does this Docker container have like the right packages? And then so the developer also shifts a little bit more like to the infrastructure side a little bit, because they will also be exposed to Docker containers, especially during testing. The build tools get more complex. Some build tools even build a Docker container. Like there are plugins to build the containers. So this is like where definitely the two groups come together, try to make the build as efficient as possible. What if the build takes 1 hour? How do you reduce it? Then developer and operations look at it together often. How can we reduce this to, let's say, 10, 20 minutes and not 1 hour to make sure that the feedback loop is shorter. So this is something, but I think it's very company specific. Like if a company says we are using Maven, they're not going to use Gradle. So
No.
often, ideally.
True.
Yeah. Or if they use Makefiles.
Makes sense.
So then, now that we are in build tools, the next thing is the continuous integration. So this is really like, how do you test? How do you get confidence that your code that you are building is actually going to deploy on production or staging QA production without having any bugs? And then, you have this test tooling, but then you have the test tooling, but you also can test, did you write enough tests using coverage? Tools like SonarQube, but there's also more SaaS products that come out. SonarQube is just some old product that it's already around for some time, so that's why I put SonarQube. We used it because it has like all these plugins. It has a lot of things, and it's used like, I don't know, quite a lot in enterprises. I don't know, like nowadays whether they are still using it, but it's like a big product.
Yeah.
And there are lots of alternatives. So like linters, code checks, security checks. So you kind of first it's a whole continuous integration pipeline. So you run your test, but then there's so much more tooling tests that go on, like coverage reports. Sometimes maybe you want to stop the build if there's maybe not enough coverage, or if there is like if your linters say you shouldn't be putting this code in production because it has something hard-coded, security check, dependency check, maybe, like people do dependency checks, and then maybe stop the build to say, maybe you should fix this dependency first. Again, we work together, developer and operations, kind of on this, depending on how good the developer is with it. And that also comes later back is that I think DevOps engineer, because they call it, most companies call it the profile they're looking for, like that. As a DevOps engineer, it's not only just writing code or making sure the infrastructure works, but then there is actually a lot of soft skills involved. There's a lot of meetings, convincing people. And when you talk about code coverage and linters and code standards, there's often a lot of meetings and discussions and with other groups, like what are we going to adopt? What standards are we going to adopt? A lot of opinions, and then you kind of need to find, a good way to make your own standard.
Like you have to run it as well, but you have to make sure that it's done like reliable and that's your liaison within the organization in most cases to it is a culture, but like often I saw it as a role as well, and you're kind of in as a liaison in the organization to help connecting those dots between those silos in those organizations. Like if you have a bigger team, then you also will have a networking team or whatever, and then you have a development team and an operations team, and then you have to all combine and start cooperating as well. But like in relatively smaller companies, that is your solely task, is to be able to convince people on this will work better if we make this improvement, and not everybody's always that open to it, but that's definitely a needed people skill there.
Yeah, definitely. Next, infrastructure as code, and going back how we got into DevOps, like, okay, build tools. Second is, well, we are spinning up all this infrastructure. Shouldn't we write it down somewhere? You remember how we used to do it? Like,
No.
yeah. Do you remember how we used to do that in companies before infrastructure as code? It's a Word document with screenshots. Click here, yeah. next, and this is how you have to do it. And then you would do the staging environment, and then someone from offshore sometimes would then take your documents, and then on the next environments he would click through, and he would call you. I am stuck now.
Exactly, because
you did something wrong in your screenshots. Yeah.
As soon as you type it in, it's already outdated, those documentations, and then you had to tweak here and there and forgot to update it, and then like it didn't work, obviously. And shell scripts weren't also not the thing to do. So
I would also give shell scripts sometimes, and then they would run it, and then you would kind of have to capture errors because the environment would slightly be a little bit different because maybe there's a firewall somewhere in a QA environment that is not in a staging environment. So then you would have to like, okay, if then this happens and this, because otherwise, indeed, the person that would then do the deployment on the other environments, they would then run the shell script and they say, oh, I get this error. What do I do now?
Yeah, exactly. And then, yeah. Sounds familiar.
So then I think the first tools that we came into contact with, Ansible, Chef, Puppet, and there's another one, SaltStack.
Yeah, exactly.
But that was really in the beginning, I think, when these tools were more how to provision a virtual machine, how to keep that virtual machine up to date. Yeah. And it was kind of before the era of immutable infrastructure, where you would say, oh, let's just build the infrastructure from scratch every time that we make a change. And one of these companies I remember that was saying that we are using immutable infrastructure. I think it was Spotify that said every time someone SSHs to a machine and makes a change, we need to like terminate the machine and then rebuild it. But a lot of people were still using things like Puppet and Chef to just kind of make sure that the machines are still in compliance, but there could still be a certain drift because you were not always sure if certain changes were made, like without the tools. Yeah. Because Ansible is basically just doing SSH and executing some commands.
This SaltStack was more like pull the config and check if the config is still okay, while Ansible was push manual, like, yeah. But nevertheless.
Yeah.
I also saw a combination then, because the next topic was Terraform with immutable infrastructure, that you could describe the actual machines, but then like you would deploy a VM, but there was always like a lot of Ansible code already there, and then it was like a merge between the two. First run Terraform, then run Ansible.
Terraform for provisioning, and then Ansible. Well, you could actually also do provisioning using Ansible, but that was not that as nice. You would then use Terraform on ALS or something. But I remember in the beginning, Terraform, like it couldn't do that much, you know.
It's not like it now. Now it's a
exactly.
programming language almost. But yeah.
So yeah, you would just provision an instance, and then Terraform would execute Ansible, and then Ansible would then put the like everything on the instance.
True.
Yeah. What? There's something still missing here. I was thinking about. So yeah, Terraform, but there was some other technology that we used in between, and I think I have it somewhere on this mind map, but maybe not here. Before we went to Terraform, and after we were using Ansible, we were also kind of baking the VMs.
Oh yeah, Packer.
With Packer, right? So you would how would that work? You would actually use Ansible still, so you would use Packer, spin up a VM, then use Ansible to provision everything on the VM. But then you would make it immutable by saying, okay, this image I don't change. Whenever I make a change, I will make another image. Use an autoscaling group in ALS, for example, to start that image, scale that image, and every time you want to make a change, you build a new image.
And then you could really well.
Yeah. Like that was just before containers.
Fastest way, but yeah, it worked.
Yeah, I think containers made everything faster, but this is like the approach that containers are now taking. You would just use with a VM, and then because it was actually not that fast, what people would do is you would pull the application. You would not put the application there. You would pull the application on that image. The application could be in an artifact on an object storage, something like AWS S3 or something, and then you would launch that version of your image with all the tooling on it, and then pull just before you go online, pull your application, start application. That worked. I think that worked very well actually. It's just so simple
compared to reliable as well. Yeah, exactly.
The complexity we have now. if you would have to explain this, like you build a VM, let's say you put the application already on it. It's just a few steps.
Yeah.
Compared to now, it's like, okay, now we deploy on Kubernetes. Let me just explain Kubernetes, but not in 5 minutes. Let me do it in like a couple of months or something, how we do it. So still in infrastructure as code, you have now also CDK, just like within programming language. Within the programming language, you have a library to interact with cloud infrastructure, for example. But also, I've seen you can also like use the Cloud SDKs or a Kubernetes SDK to write your own code. Maybe you're going a little bit more to platform engineering here, which we will talk about a bit later, maybe. Just writing code to do certain things on using APIs. So everything that has an API, you could just write code to do infrastructure as code. You still have the code to make the changes on any infrastructure technology as long as it has an API. And then Polemy, I also put it here. It's just another technology. I think when it came out, Polemy, it was like, oh, this is such a great technology, let's jump on it. But now I've seen like people coming back from that, okay, it's not free, it's also a company. I don't know. I haven't looked at it super close, so I don't know. And then you have the cloud solutions. Azure has something. Google Cloud also has something. I don't know by heart now. What does Google Cloud have?
It's actually a good question.
Well, in Google Cloud, you just deploy everything in Kubernetes, so...
Yeah, exactly. There's no need for...
Yeah, Google Cloud is like, every time we are on Google Cloud, it's just like, yeah, just put everything in Kubernetes, And then actually, yeah, I'm missing another one here. So you have the cloud solutions, cloud formation. So it's just like Terraform, but then you just write the YAML definitions in ALS, and then it will deploy on ALS, check the drift on ALS, and stuff like that. But then, which one was I going to mention? No, I forgot it again.
Oops.
Ah, yeah, I remember. Oh, my God, Kubernetes. What is it called? So you have your resources defined within Kubernetes, and Kubernetes will then launch those resources for you. What is it called? Remember Kubernetes? I will look it up and I will add it here. So Kubernetes provisioning with Kubernetes, infrastructure provisioning with Kubernetes. So yeah, you can just write the YAML definitions within Kubernetes. Kubernetes has an operator, and then the operator will just look at your YAML and then deploy it on the cloud. That's also a way of doing it. What else? Well, then we have the big one. So let's say you get into DevOps. Where are you going to deploy all your applications? Is it on the cloud? Most likely nowadays. Okay, what cloud is it? Is it AWS? Is it Google Cloud? Is it Azure? Or maybe even another one? But yeah, those are the big players.
Yeah.
Now you will have to learn everything about that cloud provider, which is a journey in itself, right? You have like some companies like our focus, for example, is much more on cloud engineering compared to pure DevOps. So cloud engineering is mainly, okay, you have all these things that I already mentioned, but our focus is now really how do I maintain, deploy something on the cloud? Yeah. On ALS, for example. So now you need to learn everything about ALS. So I just made some like example products that ALS has that you will find on every cloud provider. Cloud formations or infrastructure as code. Then you have all these databases, ALS, RDS, Elastic Cache, for example, which are very popular, which you have on every cloud provider databases, MySQL, Postgres, and so on. Redis, compute services. So you can just launch an image. But then nowadays you want to launch containers. So you have Kubernetes. You have also ECS, like which you also have in the different cloud providers. They just name it differently. It's a service that can launch a container, but it's not really Kubernetes, which is often very preferred if you don't need all the Kubernetes features. IAM, identity and access management, also a really big one on all these cloud providers because, yeah, you need to manage access, authorization, and so on. And now machine learning, like machine learning was already big, but now it even became bigger with generative AI. Oh, yeah, so SageMaker, Glue on AWS, on Azure, and Google Cloud, you also have these technologies to build your models, deploy your models,
Yeah.
and so on.
Another one I would add here is VPC, like in a sense the networking
Yeah,
inside
networking. Yeah.
inside the cloud provider is so important to do it right from the beginning because it's so impactful to switch it later on, and it's
Yes.
always possible. Like there's no harm done. It just takes some time, but like if when the network is done right, you already shield yourself from a lot of misery. um,
Best practices as well. Like how do you deploy multiple environments, staging QA production? Let's say you have 3 environments. How do you make sure that on the cloud provider that you can test your infrastructure on the 3 environments? Yeah, it's also a big one that you want to have done properly up front, because otherwise it can be really a hassle changing.
yeah, absolutely.
So yeah, it's so big, but because it's so big, we cannot really talk about it so much. But it's really like I think the best way to learn all these technologies is to go to one of these websites, Udemy or a Cloud Guru is also a big one for cloud, which is now bought by some other company that I don't remember. And Pluralsight. Yeah, so Pluralsight is a big one.
Yeah, exactly. But also just get your hands dirty and try something. Like, but don't forget
Yeah,
to turn it off. That's
yeah.
only shut
Uh,
things down after you're done with it. But like, just try and get your hands dirty because a lot of training can prepare you and get you familiar with the services. But it's like if you put all the pieces, start putting all the puzzles together, then of the pieces together of the puzzle. Jesus, woo, already a long day. Then you start to learn and start to make the connections on all those services and how they interact and what to look out for when something goes wrong. So that's definitely
yeah,
and
exactly.
every cloud provider also has like some GitHub repository with some exercises or best practices where you can just have a look at it and just follow along and deploy something on ECS like a Hello World container, whatever, something like that, just to that you know how it works, load balancing things and all that stuff. So
Yeah, the certifications is more the theory, and
yeah,
then
exactly. Because
and then you have the hands-on.
doesn't mean that like and that's another topic because sometimes there you have to
Yeah, is the
learn.
certification enough?
Yeah, exactly. Sometimes you have to learn stuff that we will never use or but yeah, they have to put it in there from a commercial point of view and like some stuff are in there that we haven't used in years or whatever, like and then
Yeah,
what
but
was it?
within an enterprise, you might be using it. It's
Might
just
be
like it
definitely.
needs to be brought.
Yeah.
But it's good to be brought. It's just the theory. So you test you kind of you learn how to for the certificate. You know the theory, but then there's the hands-on part, and then you need to do the hands-on part. If you don't have a job, you kind of build your own lab. Like you say, you do some Hello World. You see how all these things work, which is completely different than the certification. But yeah, the certification can still be handy to kind of prove that you understand the theory.
Yeah, and that you are able to process them, that you know how
That,
to look things up and stuff like that. That's also
and then the next part is the databases, and that also ties in then in clouds. It's like, okay, the application has a database, it needs to persist the data. Where is it going to persist the data? What databases actually fit for this type of application? So you have SQL, NoSQL, distributed databases, document databases. So you're going to use MongoDB or Postgres or Elasticsearch. Sorry, Elasticsearch or Elasticsearch is also a database. But Elasticsearch, DynamoDB, Cassandra, HBase. There's so many of them. There's even this website that ranks them, right? Like the most popular databases. And then yeah, those are difficult decisions. But you need to
also
know what do you need. Yeah, what do you need to know about them? You don't need to be a DBA, but
no, exactly. It sometimes helps, but I think that's more the responsibility of the like a DevOps engineer is never going to say like I want this in MongoDB instead of MySQL. We should do it. You know what I mean? Like it's more like the developer
yeah, you
wants.
should know the architecture. Yeah, yeah. The developer might have a preference. Yes, like let's say let's say the developer says we are going to use MongoDB because I am using JSON a lot and I don't really want to use MySQL. I just want to store it in MongoDB. What are my options to scale it? How many users do we have? How do we back it up? How do we get MongoDB on our cloud provider? Do we use something like MongoDB Atlas, or has the cloud provider its own offering? What is the difference?
Yeah, for sure.
And that's for every database. But yeah, that's again something that you learn on the job, because a company will not have all like 20 databases. So some have, but like for one application it's quite limited often.
But I would be surprised if they're all your problem or responsibility.
Yes. The bigger the organization, the more the bigger these DevOps teams are, or these engineering, these infrastructure teams. Yeah. So then then encryption is also a big one. Like let's say you make a connection between your app and your database. Is it encrypted? Is your data encrypted at rest? Like, what is the difference? Is your load balancer, does it support TLS or MTLS? So you have TLS, MTLS, encryption at rest. How do you get into your infrastructure? Do you need a VPN? Do you need maybe an SSH tunnel? Do you use something like what ALS has there in their offering, an SSH tunnel or something similar to go to your database, or use a VPN? Lots of decisions there to make, lots of technologies to learn about. MTLS is also a big one because it comes back to communication between services and stuff like that, giving services an identity. So yeah, that's also definitely interesting. And then let's say that you finally get traction. Your app gets the traction within a bigger organization, if it's like an internal app, or you're in a startup, and then finally your app gets some traction. Scaling. Like, how do you scale? Suddenly, let's say you scale the app, it becomes a distributed system. So what do you have to think about? You cannot just write data locally. If a client goes first to one instance and then to the other instance, it can lose some of the state. But also resource management. What we see a lot is that once you have to start to scale, suddenly your bill jumps 10x. And how is it possible? Cloud should be scalable, but you maybe didn't think about how many resources you need extra to accommodate for more users, and suddenly the cloud bill goes up like crazy.
Oh yeah, absolutely.
And then again, go ahead.
And together with your developers to see what pieces can then be maybe split off into other services or something like that is always a way. But like and that's also a good thing, that you are able to maintain that load and not back like in the day that you have to go to the hardware vendor and rush to get some machines in the rack, that you basically can just delay that problem without having to impact your users. You pay for it, which is inconvenience, and it's sometimes costs a lot of money, but you're able to just pay away the problem for a couple of months or whatever, depending on your runway. But there's actually a way out, and then you can optimize. It gives you headroom while if something goes wrong and you have to fighting fires all the time, this buys you time, and literally it buys you time. It costs a lot of money, but yeah.
Yeah, I find it interesting when you read these books about the big companies we know now, like for example Netflix, or products like Instagram. Like, what happened when they had to scale? Like in the Netflix case, they were like, "Oh, we bought this massive server. Now we can have thousands simultaneous users." 2 days later, it's like, "Oh, I think we need to buy some more."
Yeah, exactly.
To the hardware store.
Always so good, but. Was it Facebook, or was one of those that had to run around and bought everything that could run a server workload in proximity of how far, whatever, even from companies that were not using it, they were counting, do you have still some servers capacity? We let us buy them, we need them for. So luckily that's just nowadays it's just the cloud vendors, their problem.
Indeed, I remember when we still were putting data service into data centers, that there was this local social network in Belgium, and they suddenly also had pallets of servers and oh yeah, we need more capacity, and they were pushing more servers in those racks, and then
Yep, absolutely.
yeah, those were the days. But yeah, I mean, not every company's on the cloud, right? So some companies are also doing that. Twitter also moved recently some servers from one location to another location. So this still exists, right? It just, for companies that's not like X or Twitter at that level, they will probably just do something like cloud or a small on-prem data center. Maybe they don't really have this some scaling problem, but even when you are on cloud, it's just so easy to scale now. But yeah, you want to do, and that's what I noted down here, cost-effective scaling. Not just like, let's just add more resources possible, but indeed, like you say, you buy some time, but then after you bought some time, you still need to remediate all the technical debt you created by optimizing, by changing it to also to lower your cloud bill. And then you also get into these CPU architectures, Intel versus ARM64 now, like which is more performant for your application. Is it less expensive to run on different architecture, and then performance optimization. So yeah, this is also something that you need to be aware of. And another big one, observability. Prometheus, OpenTrace, cloud monitoring alarms. Yeah, this can be also very cloud specific. And also you have tooling like Datadog, and then other companies, but those are very expensive often. The cloud solutions are often cheaper, not as good, but cheaper. I remember now just this company, I don't know, like some crypto company that had this massive Datadog bill.
Oh yeah,
Like
exactly.
what was it? They were paying millions
10
in
million or something like that, and then you
yeah,
just
this
keep
is
wondering, like,
crazy.
let's just say you put that budget to solely to like that or whatever, but just imagine like that. So weird. Yeah, people will not see this in the
I can edit it in.
Zoom all of a sudden, like shoot balloons behind me, but whatever. No, what was it? Oh yeah, like for 10 millions, let's say you have 10 millions budget. Let's hire a development team and just build a tool that fits our needs. I think you can rebuild it. No?
Yeah, but I think that what you just said, like this buying time, I think this was happening. It's
Yeah,
like, okay,
true.
we have the money, let's just you know
True. True.
but yeah, it's
We will.
not.
Why we send them petabytes of data? We will figure it out
Yeah,
later.
yeah. It's just someone said like, I think I have a bug here. I will put my debug level on tracing, right? And then we'll see what ends up in Datadog. It
And
must
then
be
we
something
push
like
it
that.
to production,
Now push the production.
20,000 instances. Yeah.
Yeah, something like that. Yeah. Next, microservices.
Yeah.
We have another episode about microservices, but within microservices, communication between the microservices, RPC, gRPC, source-to-source tracing, again, something like Datadog, OpenTrace, Prometheus. There's also like these open telemetry products where you can put your tracing to Istio. So once the service mesh basically, right? So it's actually service mesh because there's more service mesh products. Istio.
Nevertheless, there are more.
Yeah, there are some other ones. So yeah, like once you do microservices, authentication, authorization, encryption, redundancy. Yep. There's retries, identity of a service. So there's a lot of stuff going on there. Now we finally got on the right part.
Yeah,
almost there. So there is so much in this industry, right? And
I
that's the
hope
thing
people
about
are not filling it in YouTube and then landing on our podcast and then be like, I can learn DevOps in like, I don't know what timing we're gonna end in an hour and 20 minutes. Okay, I'm just gonna follow this, and it's just the explanation of what you best know before starting into the role. Yeah.
In 1 to 2 hours, I just can give you a list of things that you need to know.
But you don't need to know everything into detail, but you need to know that they exist and how they work.
I will tell you what the problem is. The problem is, like, you don't know like let's say you're gonna start work, you're gonna go for an interview. You don't know exactly what technology this company is using, but the way they're gonna ask that question is completely biased on the technology that they're gonna use. So if you don't know anything about microservices and they're like a microservice shop, they will ask you, like, tell me about Istio, service communication, identity of these services, and you're like, oh, I don't know anything about microservices, and that's sometimes like it's so like because it's so broad, you can like do a deep dive in one topic, and then it's just a topic that you don't know much about, and that's a little bit of a pity, like the way that interviews are done. We actually what we do, and that I found quite interesting, is just send all the questions that you're gonna ask or like the general topics to the person that you're gonna interview a week before, and say we will talk about this, and then they can still fill the gaps because you cannot never know everything, and then you can actually do a deep dive. You can then ask, so tell me about this, and then go a little bit deep and see like how much a person knows about it. But just like, okay, there's this 1,000 technologies that you could know about. Let's take this technology, and I'm gonna ask a lot of questions about it. Yeah, that's often the story.
Name them all.
Yeah,
Like, and also in the way that we conduct those interviews, there's no wrong answer. It's just like how you fill it in, and that's also something that we try to get across to the people we're interviewing.
Yeah.
They're like, there's no wrong answer. It's
On
just
an
like,
architecture level, you mean?
yeah. It's just
Yeah,
like you would do it, and it doesn't mean that it's
indeed.
wrong. But yeah, that's beside.
Yeah, it's like, would you run a Kubernetes cluster for this one app? And then maybe there is a reasoning behind it. Oh yeah, because this and this and this.
Exactly.
I can run a Kubernetes cluster super cheap on this cloud provider. This is how it's done. Yeah, there's always. Indeed, you need to kind of be able to defend the arguments that you are making. And if you can defend it, then it's all good, I guess.
Yeah, sure.
So yeah, soft skills are already mentioned.
Yeah.
But yeah, it also depends on the company, I think. But definitely there's a lot of meetings, so you need people skills. There's in DevOps, yeah, it's like when you go more about DevOps is a culture. So indeed, if the company is doing not the, let's say, writings, not the way it should be in DevOps, yeah, then there's still organizational change management. Like, how do you change from doing one thing to another thing, and then having lots of meetings, convincing people, getting organizational buy-in. That's what also noted down here. Now you have to start convincing people.
Yeah, absolutely.
Maybe write documents in like, what are the pros, how it's going to change, how are we going to change, how are we going to do this migration. Maybe not on a technical level, but more on like organizational level, how are we going to change the way of working, and also being able to explain to a non-technical audience. That's a difficult one, right? So yeah, why should we use Kubernetes, or why should we not use Kubernetes? And that explain that to a non-technical audience. And then it's often, yeah.
Or explain to customer success why the app is down. Which also sometimes happens.
I think kind of a shortcut in convincing people why to use a certain technology or why to do something is the cost. So if you can say, we should use this because it's going to cost us 10 times less, nobody's going to be against it.
No.
Okay, yeah, but then the argument is then, okay, but maybe in 2 years we need all these other features, and then okay, maybe it's cheaper now to use this technology, and then when we need all the features, we will migrate to this other technology. So yeah, soft skills, and then back to the hard skills, or more like on an architectural level, maybe like deployments. You need to know about the deployments. What are the strategies of deployments? Can you do rolling or blue-green? What are continuous deployments? Yeah. How many times can you deploy in a day? Do you want to increase how many times you are deploying? If you maybe only deploy once a month, you want to go to every week, multiple times per week. And then, of course, you come into the world of Jenkins and others, pipelines. So Jenkins, GitHub Actions, Bitbucket pipelines, GitLab pipelines. So they all have their own way of building, testing, deploying the app with plugins and so on. So super. And then again, yeah, it again depends. Like, that's actually a funny thing as well. Like, what is the stack that the company is using? Is it using Jenkins, or did it go to GitLab, or is it using GitHub Actions, or Bitbucket? And Bitbucket is then Jira and the whole Atlassian suite. So it again really depends on what they're using. Version control, Git. You should know about Git, how it works. And then in our time, but CVS you had first, and then
VN.
Subversion. SVN is CVS was before that, I think. CVS, SVN, Git. So,
Yeah.
but we are very happy that there is now Git because these other technologies they had some
shortcomings. Let me put,
so
put it that because a
yeah.
lot of evolution went into Git came out basically.
Yeah. And apparently, and I read this the other day. So Linus, like he's the owner of Linux. He just first put everything in his head. How should it look like? And he was thinking about it, and then he just programmed it. Apparently,
Okay.
that's what I read. Yeah. So first he thought about it really deep, like this is like how should it be?
Yeah.
And then he just kind of programmed it.
Yeah, amazing guy.
So version control, GitHub, Bitbucket, GitLab, Azure DevOps. So it depends on what stack that you're using. And then for deployments, yeah, if you're not in containers, and containers are made a separate topic, then you do VM deployments, and then you maybe go back to things like Ansible, but Packer, you package your VM deployments, or use some cloud technology or some hyperscaler technology to build an image.
Which also works quite well. But then you have
Yeah.
reliable, like that the machine that you got last week, that is the same machine that goes to production. And that was the thing that was most of the times lacking. So that's all also a super good way of doing it if you're not like in cloud or containers. Yeah, absolutely.
So if you are in containers, well, you have to know about Docker.
Another thing that you need to learn, but it's super useful.
Yeah, Docker is the kind of main one that got it all started, but nowadays there's no Docker anymore in Kubernetes. So the way it starts containers is using containerd and some other technology. So whereas you would still use Docker, because now there's also bigger companies need to pay Docker if they want to use it, so they might also use something else, some other client tooling to build containers. There's like Podman, there's other technologies to build containers, but you kind of start with Docker. That's the easiest. You build containers, you deploy the containers using Kubernetes or maybe some cloud container orchestration, ECS, Cloud Run, other container orchestrators.
For sure.
And then if you want to deploy on Kubernetes, then you use Helm or something similar. Maybe operators, Kubernetes operators you can also use, but Helm is quite popular one. So that's also a packaging of Kubernetes. So you see how deep you are going now. It's like, oh, you are talking now about, okay, how we're going to deploy something, but how we're going to not really package the app, but package the way of deploying within the Helm chart and then deploy it on a Kubernetes cluster. Now, the interesting thing about these Helm charts I find is that they can, let's say you have Kubernetes, but Kubernetes is like, it's not, every Kubernetes cluster can be different. Mm-hmm. Like every cloud can be different. So your Helm chart might have a lot of logic if I'm on an Amazon AWS Kubernetes cluster, I'm going to do this and this and this. But if I'm on an on-prem cluster, I'm going to do this. But if I have this technology, then maybe, or this I don't know, capability, then I'm going to do different. So these Helm charts can get really complex. And that's why Kubernetes can get really complex. So within Kubernetes, there's often also an API gateway. And even outside Kubernetes on cloud, you have the AWS API gateway, for example. So you have the API gateways of the cloud provider, but then you also have the API gateways that you would run in a Kubernetes cluster or on-prem, like Envoy is now pretty popular. So Envoy is also the proxy they use in Istio, but it can also be an advanced ingress gateway. Kong is another one. So there are also a lot of Glue, I believe, is another one. There's a lot of commercial solutions there for advanced API gateways. So yeah, like if a client connects to your app, you have this API gateway sitting in between to manage the routes and to maybe manage cores, authentication, rate limiting.
Yeah.
So there's a lot of layers before you even
Get
get to
to
the
your
app itself.
deployed app. Yeah, exactly.
Yeah, indeed. You keep on creating layers.
Yeah.
Yeah, and then you can have an advanced ingress gateway and then a service mesh, so that you first kind of hit the gateway, and then MTLS communication between everything, and then you have microservices, so you can then hit one service that then can communicate with another one. There's some nice diagrams that I saw online, like traffic in our Kubernetes cluster, and then like you should see all these nodes, and every node is a service, and everything is communicating. So yeah, can all get very complex. And now just some things on the side that are interesting to learn, that might can come up within DevOps. But I think we kind of already had like the core. Once you go to Containers Cloud, that's like the core things that you need to know, like the basics. And then now something like, once you deploy on the cloud provider, something big that people often underestimate is the complexity of identity and access management. Like, it's so big. And then here, OIDC is one method for authentication. SAML is another one that is being used. But then now you just talk about, how do I authenticate into an app or a cloud provider? Often organizations have a separate team for that, right? So you might not come in contact with that much, depending on what organization you're in. Not that deep, yeah. So then you have the identity providers, something like Okta One Login, that you can also connect to your cloud provider, but that's typically linked to every service that the company is using, like also to Atlassian, Jira, or any other tooling.
Yeah.
And then within all that, then you have access-based, role-based access controls. I just put RBAC here as a role-based access control because you have it in your cloud provider, but you also have it in Kubernetes. So you have then all these roles that you have in Kubernetes, these permissions that you can give on an API level. So actually it's pretty similar. So in ALS, when you do IAM, you give you build your policy, and you say, I allow access to I don't know, S3 but that's also just, you give access to a certain API endpoint, like a user or role to a certain API endpoint. It's the same in Kubernetes. Like, if you say within Kubernetes, I give you access to the API, the Kubernetes API, you're also saying, oh, I give you only access to this bit of the API. So yeah, that's super complex. I mean, I think people underestimated how complex access control is on all these different systems. And then if your company is in machine learning, you might have to do some machine learning operations. How do you train a model? Like, what is the infrastructure that you need to have to train models? What is the infrastructure you need to have to do inferencing? You want to do ETL? You want to do distribute?
Yeah.
Distribute ETL, Hadoop, maybe. Hadoop cluster. Hopefully not. Hopefully you have some managed service.
Exactly.
Apache Spark is often, like, Amazon has managed Apache Spark. Google also has some great products, their managed products. Amazon also has Athena. Athena can also do Apache Spark. So there's a lot of products that you can do to do distributed ETL. But distributed ETL just mean, let's say you have a terabyte of data. You don't just gonna download a terabyte of data and then do the transformations. You're gonna kind of make chunks out of it. It is already chunked, often in object storage. So you're gonna have maybe 10 workers pull each of them gonna pull a chunk, and then every node is going to do some transformations. Yeah, and then maybe bring everything back together. So you have the MapReduce. MapReduce is also used for that, but also other ways of doing ETL. So yeah, this is like a whole other area, but you may come into contact that if probably. So, but you also have a lot of managed services within cloud providers to help you doing this. SecOps. So if you then work with security teams, the security team says, you cannot deploy anything with a security bug in it, so stop the build. make sure it's automated, put that in the build, that actually you do all these checks in the build for examples, use the linters, use dependency management. You then also have this external tooling to
do that for you, kind of.
to integrate, to do that for you. But yeah, you still have to make the decision whether you're gonna stop the build or just gonna have some alerts. Yeah.
It depends.
So that's also an interesting one. Actually, the most interesting about it, I find that it's also kind of up to the developer team to choose whether they have a lot of dependencies for every single small thing that they want to do. They're just going to introduce another dependency, or you have like programming languages like in Go, Golang, where there's already a lot of functionality within the core language, like modern things. So that you don't need too many of external packages, and you can do quite a lot with just plain Go and the standard packages. And then if you take a look at JavaScript, Node.js,
oh yeah,
well, you just start out and then your Node modules is like a couple of gigabytes of Java code, JavaScript code. Yeah, indeed. And then packages get abandoned, security bugs are not fixed. So, I mean, not saying JavaScript is bad. It's just more effort. It's just more effort to keep everything up to date.
And luckily, there are tooling for that. So yeah, it's like you said. You have to make a decision if you want to stop the build or let it just go through and get an alert from it. But yeah, like we all feel what's best here. But
yeah,
it obviously depends.
Yeah, but indeed, like you might not be the only person within your DevOps engineering team. So you might have 10, 20, you might have multiple teams, depending on how big the organization is. So, and then maybe it's not your responsibility to manage dependencies. Maybe it's purely the developer with some external security team. So it all kind of depends. But yeah, these things are like, if you then go for an interview in a small company, they might just ask you, so how do you do the dependency management? So you still need to know something about it. I would use this tooling,
Definitely.
Platform engineering. We did another episode about platform engineering, right? So difference with DevOps is just you would kind of create a platform for the developer, self-service platform. So now you become a product team, kind of. So you need to know programming. Golang, Python is quite popular. Definitely, there's more. Kubernetes, you have the operator framework that can be used within organizations as a platform. Like developers write YAML files, deploy it to the Kubernetes cluster, and then you are going to do something with those YAML files. You're going to start databases. So
cool applications.
I read that there's quite a lot of people doing this kind of stuff with operator framework. But there's also, you can just write an app, interface with a cloud provider, with all, like everything is an API nowadays. So you're just kind of writing APIs or writing REST calls with some business logic specific for your organization, platform engineering. But yeah, you need, because it's now a product, you need to know about the software development lifecycle. You're writing a product even though it's only internal. Now you become a developer, so now you need not just only operations. Now you're a developer and doing operations of yeah. But yeah, you can have a DevOps team and a platform engineering team. And so as a platform engineering, you're just then developers building something internally on the infrastructure, but you might still have DevOps teams that helps you with the pipelines, helps you with all the other things. So best practices, like what we discussed, for example, the other day, monolith versus microservices. When you do use one, when you use the other one, when you use a monorepo, 12-factor app, I find is a good one. Was it 12factor.net or something, or just when you type it in Google?
It's available in every language as well, and it's a very good step to make people aware that, especially developers that were not aware of developing on the cloud, what the implications that it has. Sometimes, it's a good guideline, and it's not, there's nothing new in it, but it makes it gives you 12 good steps on how absolutely make your app runnable on the cloud, reliable, without having, when you have immutable infrastructure, that there's no state lost and all that stuff. It's good stuff still.
Yeah, but it's also already quite old, right?
Yeah,
I think it's like
definitely.
more than 10 years old that this has been published, and yeah, it's just some good guidelines. I think
Yeah, for sure, for sure.
if you build your app like this, you will be able to deploy it anywhere, kind
Yeah,
of.
yeah.
You will be able to deploy it anywhere, but nowadays you would still need a Helm chart, lots of logic in there, and then you can deploy it anywhere on a Kubernetes cluster. Um, yeah,
12
so
star.
yeah, tough like start, yeah.
might be might be 15 factor. No, no.
12 factor, and then that's actually just for the developer, and then you have another 20 factors here, and then yeah,
That's how the magic happens.
because also we didn't really mention it, but Terraform and all these other toolings is nothing that we discussed is actually cloud agnostic, right?
Nope.
It's not that there's one tool that can deploy on multiple clouds. You could, and actually, if you go back to platform engineering, you could make a platform that can actually
Mhm.
deploy to multiple cloud providers. But nothing of this tooling that we came across, I think, is really um, inherently cloud agnostic.
No,
It's always like you kind of deploy on one cloud, you kind of pick cloud, and then you stick with it. But if you look
absolutely.
at, I think maybe Netflix or like companies that are really multi-cloud that can move load from one cloud to another, then you go into platform engineering and you write your own software to make sure that when you do deployment, you go through your platform will then maybe redirect the traffic or deploy it on one cloud or the other one. So yeah, platform engineering is actually a big one also here. Maybe you will never be exposed to it, but it's still a big thing, especially if you want to build some complicated architectures. So yeah, I think the last one is like, yeah, some good books. I didn't come up with a lot of them, but I just put like, what should I read if I only can read one book, kind of, because
Yeah.
there's so many books you can read. Actually, what I prefer is to read books about companies. Like, let's read a book about Netflix. Like, how did they go from sending DVDs to everyone to actually a complete online platform? There's a book about every single startup that is now a big company. So you can read and then you can hear kind of useful lessons, but you can hear firsthand how did they scale everything, how did they work, and
And how they came up with the solutions and stuff like that. And
yes,
they're
exactly.
always good stories. Absolutely.
So the book that I put here is kind of a traditional within DevOps now. The Phoenix project, I think that's like the book that explains DevOps. So it's what everyone reads, kind of. And I find it's kind of based on The Goal, which is a much older book, which is the theory of constraints. Has nothing to do with IT. It comes from manufacturing, and
Mhm.
that's I find a very interesting book because you can read a book that has nothing to do with DevOps, that has nothing to do with IT, and still find that everything that's explained in it makes sense within your industry as well. So that's what I find, and this is a very short book, and then yeah, that's a very interesting one I find. Do you know any books or
Yeah, basically the Phoenix project.
off the
That
top
was
of
the
your
one
head? Yeah,
that I
Phoenix Project, yeah.
wanted to mention.
I also had this Google the SRE book that is
Yeah,
often
yeah,
mentioned.
exactly.
Yeah, but it's more technical. Like, it's more like how did they implement it at Google,
Yeah. Why and
which
stuff
might
like that.
not which might not be the way that you would do it. Yeah,
Exactly, exactly. It's just good. It's like a documentary more than it's like a
a
conceptual book.
technical, it's much more technical because the Phoenix project. If your company is not doing any DevOps, the Phoenix project is like you can buy 10 copies and hand them out to all the management
Yeah,
people, and they will understand what it all means. Yeah, but not the SRE book.
no, yeah, exactly, exactly. And one thing I want to add here as well, because we kind of worked our way through our mind map, is the like the personal advice maybe a bit as well. Like, don't feel too intimidated about this chart. Like, it is a lot, but like we said in the beginning as well, it's like you will learn this incremental, and also when you get hired by an organization, at most cases there will be already somebody there, or if not, there will be already be something to start with and to that runs and that works, that obviously can probably need improvements and stuff, but don't feel too intimidated. That's how I got into the role as well. um, like, obviously it was in steps, but then I made the switch from being Oracle DBA to a DevOps engineer, and it was in the beginning, it was like quite intimidating. But then, like, I still remember going to San Francisco, was super excited that I finally got out of that. It's weird to say, but like that the corporate Oracle stuff working for banks to like a startup in San Francisco. That was like a dream. And then I still remember getting off the plane, going into the elevator, come across in like this
Now you're
typical
DevOps engineer.
thing like pirate flags, high desk, standing desk from IKEA that weren't standing desk, but they just put blocks on there, and there's sofas and like basketball ring, like all that stuff. And they were like, "Ah, you're here. Nice. We have an issue. The deploy failed." And I was like, "Oh, but I'm just here. I don't know how everything works yet." Yeah. And then they were like, "Yeah, see." And it was like, we did a deploy, but the system says it has no disk space left. But if you look at it, there's still disk space left. And I'm like, but did you check if like their inodes, maybe the inode capacity? It was the first thing that came to mind because I already did that LPI and all that stuff. I had that basics thing, but I wasn't that familiar with AWS back then. And then it was like, oh yeah, that was it. There were like a lot of open log files, small log files. They deleted and deployments. Oh yeah, hero. And I was like, okay, maybe I will be able to do this actually, because I also looked at it from on this mind map and I was like, oh, I need to learn everything. Not everything, you have your basics, but as long as your basics, they kind of all add up to something really, really cool. And it's a super enjoyable role, and you will not like kind of be sad about that you chose to go this path either way. Don't feel too confidently, because then things will break, but like somewhere healthy in between, I think is a good. Do you have any advice for it?
Yeah, I think okay, we went over the whole like what can it encompass, but don't forget that there are also in bigger organizations the Jenkins engineers. So like you could just kind of take any technology here and just say, oh, there are people within one organization that are just only responsible for this specific part. So this is more like, okay, this is everything you could come in contact with, but your role in an organization can only touch maybe a little parts of it. So it's good, but indeed, like you say, you kind of start with one thing and then you kind of branch out. So maybe you start as a company building pipelines in Jenkins, but then there's a migration going on to GitHub, and then you know GitHub, and then okay, they are using ALS, and now you know a little bit of ALS, how you deploy it on there, and then oh, they are deploying to Kubernetes. Okay, now you learn about containers. It's like you need kind of you have a starting point somewhere on this map, and then from there you kind of see how it connects to other technology. Yeah, you then learn the next technology, the next technology, the next technology, because you can indeed learn this all up front, but you should have an idea about everything, which you already have now if you watch this video, but just that it exists is already quite a lot. And then that you know that it endpoint is for an advanced gateway, so that you have a keyword to type in if you need an advanced gateway to get started, you see. So you definitely don't need to know everything. And I think nobody knows everything. Everyone has his field, his specialty. Someone will be more of a cloud engineer, someone will be more on the Kubernetes side, someone will be more on the machine learning side. And then you often, like I said, you're often not alone. You will have a specialty.
For sure.
So you call it another specialty.
And also technologies come and go. Like we've
seen
multiple things come and go. And
try to find Puppet and Chef. That's I think like where you could find it so much 10 years ago in every organization. Maybe now it's all less because we want to go into Kubernetes.
Exactly. And also at the end, it comes down to being flexible to adapt and to be able to learn and read documentation, basically, and know where to find information. Not a Stack Overflow from 1994 with like whatever and just copy paste it and hope that it works, but really see like, this is reliable information, this can I use, and then that will help you along your way, and you will be able to filter it quite easily after some years in the industry.
I think that's a great point what you just made. Let's say going back as your job as Oracle DBA, it's very contained, one product. you'll be an expert in this one product because we hired you as an expert of this one product. Whereas being in as DevOps engineer or cloud engineer or whatever, there's lots of technologies to learn. It's more like 30,000-foot view that you need to have. Okay, we have this, we have that technology, and you, like I say, you need to be willing to every so much time learn something new. AWS comes out with a new product. Google Cloud comes out with a new product. There's something new in Kubernetes. Everything. This is still all ongoing. There's all new things coming out. Whereas if you are just within the DBA space, there's not. I mean, of course, there's also new things coming out, but it's much more contained. New versions. Okay, now there's a new version, but only when we upgrade to this new version, which will take us 6 months, maybe a year, then we will have these features. Yeah.
Absolutely. Yeah. There was and that's the thing. Yeah, like you said, in bigger organizations, you have multiple people. You have DBAs, but you need to be able to know what a database is, where to look for performance issues, that you can already like start cooperating between developer and operation teams, and it's just adapting and learn how to interpret the information. But that's where all those toolings come into, like the observability, all that stuff. It's all made for that. So I think we already covered a lot of things here. I'm not sure. I probably missed some things that are super important.
I'm sure we missed something. Like we will put this video out, and then I will tell you. This technology we didn't mention. Oh my god.
If you all of a sudden are wearing a different T-shirt, the lighting is different and all that stuff, and then be edited.
Edited in middle. So by the way, this technology. I think what is interesting, and it's definitely the story that you just told that is interesting. Like, how did you get into DevOps? And that's one of the next episodes that we should definitely talk about. It's like, how did we get into DevOps? Like, what was our journey? And that will also be, I don't know how deep we will go into the details, but yeah, we could talk a very, very long time.
None of it is still NDA, I think, because we're so old already. So
yeah, we'll cut up the videos in the episodes in decades. Although we're not even that old. I think we're not even that old. We just kind of are a long time in this industry, and we start quite early. That's the thing. It's like some people, they really start when the first job start. We kind of started already a bit earlier, like
also with hobby projects and stuff like that.
But with the hobby projects, exactly like that.
But
yeah, it was good. Yeah.
Exactly. Else we will just to it, and then like maybe you can lift the tip, but because it was not that common that people had like computers from a young age when we were like, I don't know.
Yeah, you would still have the desktop computer in your living room, right? And then if you are the person that's kind of builds the computer, you already like, and then yeah.
But that's more for the history and the other episode. All right, I think we can wrap up here. Thanks everybody for staying on for this long and this on the DevOps journey.
And the technologies we forgot, you can always put in the comments.
Let us know. It's super important, like, because
you need to cover this technology because that's what they ask in your interview. Exactly. And I think like within a year or a couple of years, there will be definitely new technologies that are super important that we are not mentioning.
Yeah. Absolutely. I'm looking forward to it.
Yeah.
Right. Edward, take care, and I will see you soon.
Have a good day. Bye.